Hello. How's everybody doing?
Howdy.
Hey. You scared me a little bit. I was looking the other way and I jumped a little.
Well, you better expect the unexpected, buddy.
Yeah.
Okay, I see that screen. Oh, no. Okay, I need to sign in. Let's see if I can do this. One moment, and I will enable screen sharing.
No problem.
Hope everybody had a great week last week.
Yeah, I had some time off, so mostly took naps, I would say, for me.
Nice. Ooh, is it going to work? Excellent. Okay. All right. Screen sharing has been enabled.
Can you guys see my screen?
Yeah, let me do my little spiel that I mostly forget to do, but I didn't forget it today. All right. Welcome, everybody, to the November 30th, 2021 meeting of Kubernetes SIG Multicluster. We are going to start out today with a presentation on Work API, and you can go ahead now.
Hey everyone, can you see my screen and hear me clearly?
Yes.
Yep.
Thank you. I'm Mike, a developer from Red Hat. First of all, I want to thank the community for giving me an opportunity today to do a quick overview and demo of the Work API project. Before I get started, I want to mention that this project was created and mostly contributed by Hugh Chang, who is also a developer from Red Hat, but unfortunately, due to the time zone differences, he won't be able to make it to this meeting. So the Work API is basically a common API to distribute workload to multiple clusters. Some background information, first of all. This Work API project was mostly inspired by Valerie Lancey's multi-cluster workload blog post and the prototype, which basically describes a group of set of resources and apply them to one or more Kubernetes clusters as work or workload. As of now, we're keeping the API simple and it's only responsible for describing the list of work. It needs to be deployed to a single cluster. The motivation that we want to do this is it allows developers to easily integrate with other source of truth, for example, GitOps, or use other Kube API servers. We made it simple so that it's easy to integrate with other placement primitives. And then the goal is to have a CR that basically tracks which cluster a particular workload is deployed to, and then it tracks the deploy resources on the cluster so that the control loop can do a garbage collection on those resources. Some terminology that I'll keep reusing over the course of this presentation. The work hub is a place where the Work API resides. It doesn't have to be a Kubernetes cluster. It can be a RPC server or cloud API, depending on the implementation. But for the rest of the presentation and the demo, it's assumed that the work hub is a kube cluster. The spoke cluster, or sometimes called managed cluster, is the target kube cluster where the workload will be delivered to. And finally, the work controller is a controller responsible for reconcile the work object on the work hub and apply those resources defined in the work to the spoke cluster. A quick overview. For more details, visit the Git repo, please. The a work CRD is to represent a list of Kube API resources to be deployed to a Spoke cluster. The work CR is created on the work hub and sits in the namespace that the work controller has authorized access to. Creation of the work on the work hub means the resources defined in the work will be applied to the Spoke cluster. Update of the work will trigger the resource updates, and deletion of the work will delete the resources and garbage cleanup on the Spoke or managed cluster. Just a quick side note, deletion is not yet implemented in the current project reference implementation. Part of this presentation and demo is hopefully we gather some interest from the community and we improve on the API specifications such as delete policy, for example. Looking at the diagram, we can see there are multiple Spoke clusters. So multiple work agent controller will be running that monitor the work API in the same or different namespaces on the work hub. It's totally possible that the multiple work controller watches the work in just one namespace on the work hub and deploy the resources to the multiple Spoke clusters. In the diagram, as well as the current reference implementation, judging by the arrow that's pointing, it's using a pool model where the Spoke cluster has an agent running that watches the APIs defined on the work hub, fetches them and apply them locally on the Spoke clusters. Um, a, a push model can also be implemented. A push means that the controller on the hub watches the API, define the workload, and pushes the resources to the managed cluster. There was an active community discussion over push versus pull. As of now, the work API doesn't restrict you to use either of the models. It seems like the general consensus is the pull model has some advantages, such as least amount of external attack services, because all the Spoke cluster doesn't need to be exposed, and they just need to communicate with one hub cluster. But maybe the implementation for the pool model is more complicated than push. So there's plus and minuses. But again, the work API spec doesn't restrict the users to use either push or pull. So looking at the current spec, not everything is displayed on the screen. Feel free to visit the GitHub repo for more details. The work spec basically just defines and describes the list of workloads to be deployed, applied to the Spoke cluster. Again, there are some detailed discussion around if we should use the one-time WAR extension as a way to wraps all the workload, because that really opens up the API, and that's another topic that we hope the community can provide some feedback on. The current status is pretty straightforward. It describes the progress of the work being applied, as well as for each individual workloads. It can describe the resource status on the Spoke clusters. Regarding the status showing on the Spoke clusters, because there's a scalability issues, so there has been some discussion of how we can limit the amount of data to show on the work status as well. So that's another area where we're interested in getting some community feedback. Here's an example of the spec. We can see there's in this spec there's a workload with a deployment, and then we define all the deployment spec here. And a status example, once the work is applied on the work hub and propagate down to and delivered to the Spoke cluster and supply successfully, and it will show the manifest condition that is being applied and the identifier, etc. So I'm gonna do a quick demo right now with the current reference implementation of the Work API. The reason why I keep mentioning that it's a reference implementation is because there are other consumers that uses the Work API, enhances it, and have been running on production. So some example is Open Cluster Management, and as well as another project called KMADA, and both have their own implementation of this Work API with some enhancements, and both communities are looking to contribute back to this project. It's really about coming to a consensus and define the API specs based on community feedback. But getting back to the current Work API reference implementation, on my left side, I have a newly created Kind cluster that's set up to work as the hub. On the right side, I have another newly created Kind cluster that's set up to work as the spoke cluster. I have the work agent deployed already on the spoke cluster to save some time, and I have the work CRD apply on the work hub. So I'm gonna be applying this example, this work example on the hub, and hopefully everything works out, and then it'll deliver to the spoke cluster. In this workload, there's two resource types. There's the deployment and the service defined in the manifest. So I'm gonna go ahead and deploy that right now. Let me apply that right now. So we can see that it's already applied successfully, and both resource deployment seems to be fine. And if we check on the spoke cluster, and the deployment is there now, and the service is there now. So that was a really quick demo of the reference implementation of the Work API. Once again, we're really looking for more feedback from the community, and please provide some feedback in the discussion, in the community doc discussion. With that being said, sorry that I went a little bit fast. Are there any questions?
Did my audio go out? Can folks hear me?
Yeah, I can hear you just fine.
Okay. So one thing that I wonder is, like, when we talk about being judicious about status updates, like of deployed resources, I think there are a couple axes. One is how much of the status do you put there? Like, do you pick like key conditions like ready, and another, or do you put everything there, or do you try to do something smart, right? And then another dimension would be how frequently do you do that, where the chattiness and frequency of communication is probably something that has like a pretty outsized effect on like overall network traffic back to the work hub. And I wondered if like folks were thinking about those different axes yet, and like sort of where the conversation landed so far on it. So
there was a proposal from Honkai Nguyen, who is the one of the implementer of the Work API on the Kamada project. He seems to want to collect most of the resource specs, but based on our discussion, it seems it might be a little bit too heavy to collect all of the resource specs. So coming from another community, Open Cluster Management, QGen has suggested maybe we can define on the work side, um, what is the status that you're looking for, through some either templating or some JSON arguments. So that will limit the amount of data that and the data that you really wanted on the workup. As for the frequency as well. So that is another topic for discussion where we know it should probably not be it should be more of a periodic sync instead of the constantly update. But that we haven't gotten into that yet because we haven't flushed out the status to display yet.
Mhm. Are there are you all having like conversations about this that other folks can join? Because I think, you know, since it is a sub project of the SIG, if I remember correctly, like it will be best to have those conversations in public, and, you know, make sure that people are able to join as they have interests. Like, you know, the more able people are to join, the more likely that you'll get additional contributions.
Right, we're drafting a proposal enhancement documents right now to mention the status concern and the delete policy. So once those proposal will be updated, we'll post in the channel and maybe come on in other community meetings where we can openly share the proposal similar to this document, and then we can discuss how to move forward with that.
Okay, that would be great.
Thanks. Actually, that was kind of that second part was my question too. Yeah, I think this is going to be a really interesting conversation because status, like obviously you want as much status as you can. The faster it updates, the more interesting tooling it seems like you can build. But obviously, if you have a bunch of clusters that are feeding status and it's super chatty, you can put a lot of load on an API. So yeah, that's going to be a really interesting conversation.
I agree. And we're working on the draft proposal. Hopefully, it'll be uploaded soon.
Great. Yeah, when you have that, I guess sharing it with the list would be a great first step. And then yeah, another community meetup like this would be probably a really good place to dig in.
Okay.
So it sounded like K Armada has started adopting it. Like, how about open cluster management? I remember that there was like an earlier form of like work API like thing in Rackham product. Is work API being used in Rackham? Yeah.
Yes. Josh, is it Josh? Josh, go ahead.
I wasn't actually. I didn't say anything, but
Oh, okay.
but
Yeah,
the answer is
yes.
It's used to both add on to add additional add-ons for the clusterlet that does the manifest work, as well as a bunch of the advanced cluster management strategies for like application and whatnot now leverage work under the covers.
And
Awesome.
And the API that both Open Cluster Management and Armada uses is very similar to the Work API, but there are some enhancements such as garbage collections and some status update as well. But we're trying to basically come to a consensus agreement, and then we don't want to repeat the work, and we just want to draft a good proposal and then make it into a common API spec rather than we do our individual things. So that's another reason for mostly for the reason for the presentation today.
All right, any other questions about that? Thank you very much for giving a readout on this. Look forward to next steps.
Yeah, thanks. That was great.
Thank you.
I want to say that is, I can't say it. Laura snuck in there at the last minute.
I did, and I want to share these GIFs because I love them. So let me share my screen. Basically, I just wanted to give some updates of some stuff that's been going on, like some PRs that have been merged and stuff in the background. Sorry, my dog is nearby. So hopefully this is not too distracting, these guys. Let me, oh, this is my wrong self. I'm gonna make it like a real party at one point here, I think. Sorry, can't use my own computer apparently. Still can't do it, sorry. Okay, we'll just leave them dancing there for now. Okay, so I just wanted to give some updates, especially on KEPs that I've been working on. So mainly on the cluster ID KEP, there was a PR merge to finally change the name cluster claim to cluster property, which was like something we voted on a while ago. So you will now sound old school if you use the word cluster claim. So make sure that you do that, update your lingo there. Also, there was a production readiness review needed for the cluster ID KEP. It was kind of more of a like PRR light because this is out of tree, but there's some like automation that like requires that for KEPs moving to implementable now. So there's a PR merged about that. And then long ago, we talked about upgrading some graduation criteria for the MCS API. For example, taking out the explicit requirement for kube proxy implementation about directly interpreting service imports, and like tying the cluster ID API graduation more closely to the graduation scale for the MCS API KEP. So anyways, that stuff also is officially in there too. So progress continues on some of those logistical things. For example, next step for cluster ID is to submit for an API reviewer specifically. But then all of these gophers here are because I wanted to boost Jeremir's work. I didn't see him on the call when I last looked at the participant list, but just want to boost that. He worked a lot on a multi-cluster DNS plugin for core DNS, and this is or was a beta graduation blocker for the MCS API. So really appreciate you working on that, and hopefully people can go take a look at it if you want to see it, and you can enjoy these gophers for now. I probably will delete them after this because it's probably not great for everybody's download speeds for me to have a billion GIFs in here. But just wanted to boost that work. So thanks to Jeremir and Absentia if you are not here for that. So yeah, those were my updates and my GIF update.
Awesome. That's super exciting. Yeah, really excited about that that DNS plugin. Also, love the puppy snore.
Yeah, sorry.
When
it's
something
really
else.
snoring back here. I know. I'm like, I'm so professional. Ha ha ha. But actually, my dog is just like honking back here. Sorry.
It sounded like a troll or a goblin.
It is. It truly is.
To me.
Sorry, everybody.
Amazing.
Maybe it goes with the gifts, kind of, in a way.
Yeah, it adds to the whole theme. Is great. Anyway, awesome update. That's also very exciting stuff.
Yes. Thanks for the readout.
Yeah, very much excited to finally get MCS graduated to beta, and then seems like, I'm going to naively say, a short trip to GA after that.
Yeah, definitely had a little hiatus there in the middle of the year, at least for me and such, but we are picking back up.
All right. Well, excellent session today. I think that's the end of our agenda. So I'll just maybe I'll close by saying we really want to hear ideas that people have, problems you're struggling with, to the extent that you can and are willing to share things that you're independently developing. Like, please don't hesitate to throw something on the agenda if there's something you want to talk about or share with us. And everybody have a great rest of your day.
Thank you.
Bye.
As well.
See you all soon.
All right, see ya.